The Alpha Centauri star system may be the closest star to us after our own sun. Nevertheless, the journey there will require covering a longer distance than every human voyage ever made before, combined. To achieve such a mission, to travel to another star, we will need to harness the power of stars to drive our ships. Welcome back to Science and Futurism with Isaac Arthur, and today we will be looking at how we will get to our nearest neighboring star system, Alpha Centauri, what sort of ships and technologies might get us there, and some of the misconceptions we often have on this topic from science fiction and even real modern spaceflight. Some years back we did an episode on colonizing Alpha Centauri, and it went on to be one of our most popular episodes and one of our longer ones too. We had to cut a lot of material to get down to a reasonable length for one episode. One of the things we left out was the trip there, focusing instead on what we would do when we arrived. We have recently been looking at interstellar colonization strategies, and there I emphasized that we were contemplating later scenarios, strategies we would use as we colonize the billions of systems in this galaxy, not the first one. There is a big difference between the journey Magellan and other explorers took to try to circumnavigate Earth and the vastly faster and more reliable trade of even a couple centuries after, not only because engines replaced sails on ships. So too, there was a big difference between the Apollo missions, or even the new Artemis missions, and the trip made by some future spacecraft that might land travelers on the moon for a weekend vacation. I'm not sure we will have reached that point when the time comes to send people to Alpha Centauri or not, but it's hard to imagine we would send out a colony around another star before we even had established presence on a few other local planets, let alone our own moon. It is a journey that will take a large portion of a human lifetime, or even longer than one lifetime, and requires so much self-sufficiency, redundancy, and precision that I can't really see us trying it, short of some solar system wrecking emergency, until we had a couple generations of interplanetary manned missions under our belt first. And not like our experience going to the moon, where we did it half a dozen times in a few years, and then wait over half a century to set foot on it again, which still has not happened, though does seem to be ever more likely. So we might want to ask what might make us try a journey to Alpha Centauri before we had absolute confidence in our abilities and technology. We might also ask if we would ever do a scout mission, manned or unmanned, or crewed or uncrewed, before we send out a full-blown journey. Barring an emergency though, it is important to understand that while we already have many of the technologies needed for interstellar flight, these technologies require such a degree of improved mastery and casual efficiency that we cannot ignore the differences this improvement implies about the civilization launching that ship, or ships. Emphasis on ships, plural, both in the sense of sending a squadron or fleet of colony ships rather than a lone ark to one destination, and of sending colonization fleets to neighboring stars rather than waiting for the Alpha Centauri fleet to send back a report of success. But the civilization with steam engines instead of sails for their ship is also the civilization that has steam engines running its factories and trains as well. Getting from one solar system to another requires you to check the box on at least one of the following options: faster than light travel, extreme energy abundance, artificial intelligence, super recycling, or the ability to put people into stasis or freezers and bring them back to life on arrival. Check any one of those boxes and interstellar flight becomes at least somewhat practical. Now there are ways we could do it even without that, but if we tried to do it now, we would have to use the Super Orion Drive method, which is a great big cylinder ship spinning for artificial gravity powered on uranium, plutonium, or thorium fission reactions. For this method, we would need a reactor running power and life support, and actual nukes being fired out behind it to propel it along. See our episode on revitalizing the Orion project for details. Now, ships using the Orion Drive method are probably the most common type of ship to be discussed when contemplating travel to Alpha Centauri outside of science fiction, although it is pretty common there too. One of my favorite video games was Sid Meier's Alpha Centauri, where you colonize a planet there after arriving on the UNS Unity, which I'm pretty sure was meant to be an Orion Drive vessel. I was very fond of that game, so much so that it partially inspired our Life in a Space Colony series, which features the spaceship Unity in homage to it. And like many tales of traveling to Alpha Centauri, it assumes some calamity that collapsed civilization back home here on Earth. Sometimes that's the inspiration for the mission and how they were able to get the resources and cooperation to make the mission happen. But it is very difficult to come up with a plausible scenario where some kind of calamity happens, which only interstellar colonization can help with. For instance, when we were writing the Colonizing Alpha Centauri episode 4 years back, we had a devil of a time coming up with a scenario where it would actually make sense to send a colony mission out of the system as opposed to doing some prevention or repair here at home. I eventually had to suggest a rogue black hole was on a path to pass through our inner system as the most plausible, if improbable, reason for us sending a mission, as the passage of a black hole inside Earth's orbit of the Sun is very likely not only to disrupt the solar system massively, but also shower the whole area with crazy amounts of radiation. You can still find ways to survive here, and it would probably be easier than moving to a new system, but it was better than the normal rationales given in sci-fi. Basically, it almost never makes sense to flee the solar system to save humanity. Having backup colonies tends to make sense, but fleeing an alien invasion or murderous AI in a spaceship, which are incredibly easy to spot, is unlikely to work well. It might be worth trying, but it basically requires indifference or incompetence on the part of the AI, aliens, or alien AI. As for terraforming new worlds if we wreck our own, it would be easier to make Earth habitable again, even if we turned the whole atmosphere into a smog bank, or even outright nuke the airs and sea off the planet, than making a place like Mars livable. For that reason, I don't see us trying to throw together some desperate mission to Alpha Centauri. So I think we need to instead think of things in the context of what sort of civilization is sending a mission to Alpha Centauri in the context of something more like the Age of Sail explorers or the space race. We should imagine ourselves on the committee planning to approve such a mission or send them back to the drawing board to await further advancement to make it cost feasible. And I think that means we have to also assume we would never spend more than 1% of our economy doing that, whether that was GDP or gross domestic product for a year of a major nation like the US, or the entire Earth, or even the colonized solar system, the gross system product perhaps, really is more of a political question. Unity tends to come to mind for the simple reason that a unified humanity has a lot more resources combined than separate, and presumably doesn't need to spend as much on defense or watching their neighbors, so has more to spare, in theory anyway. But you can also make a good case for competition initiating progress too, just look at the space race. Trying to estimate the cost of any spaceship that's never even been fully modeled is a bit of a futile process, and one likely end up doubling or more when production time comes, but we generally feel we can make an Orion nuclear pulse vehicle equipped with 300,000 megaton nuclear devices and massing 500,000 tons for about a tenth of the US's current GDP, a few trillion dollars. I do think that's conservative, but it does mean that given a few years and global cooperation, we probably could make that happen without it bankrupting us. That is an enormous ship, 5 times the mass of an aircraft carrier, and comparable to the largest ships ever made, giant supertankers like the Seawise Giant or Battleless class. And yet it is pretty tiny for a ship that not only needs to bring along many hundreds or thousands of colonists, but those colonists all need to survive on a multi-decade journey and make a home on a strange new world at the other end. This implies a lot of cargo needs to come along, and is part of why advanced automation, manufacturing, or nanotech is so handy if you've got them. And multi-decade journey is being generous. That design is from the late 60s and has seen some informal improvements since then that we discussed in the aforementioned episode on revitalizing the Orion project. But the best guess for speed is about 3% of light speed and an arrival time of around 130 years. That is insanely quick too, roughly 10,000 kilometers per second, and hundreds of times faster than we usually get out of our spaceships. That speed is achieved by a couple weeks of launching nuke after nuke out the back of the ship and riding the energy from the detonation, which is not too dissimilar from what rockets already do, just scaled up. The century-long journey means you also need a ship that can last for that long, and that includes maintaining the portion of the bombs needed for slowdown, maintaining the reactors that power it for decades, patching leaks in the hull, and replenishing the air and water that seeped out through them, growing food to replace what's been eaten, and recycling the waste, and 10,000 other minor details, many of which we probably don't even know yet, and time and experience with interplanetary ships and colonization will make us far wiser in that regard. Odds are good even then though that some of those minor details won't be known to us until that first interstellar voyage of decades, and being trillions of miles from home is a bad place to have a breakdown. Little problems have a way of becoming big ones when you're far from home and short on backups and manpower. And this is why I tend to feel such a voyage would not happen till we were a bit beyond the Orion Drive level of interstellar ships, or had been using them so long as to be very comfortable with both them and space travel in general. It is also why multiple ships would be nice, though generally bigger ships will be more efficient than an equal mass in smaller ones. And I would really emphasize that bigger is better when it comes to human colony ships. Now, I mentioned a few things that would take us to the next level for interstellar travel and which I think would make it practical, but the Orion Drive is our fallback if we still haven't made any major improvements to drives after a few centuries of spaceflight and settling our solar system and our Oort cloud. See our episodes Colonizing the Galaxy or Colonizing the Oort cloud for more discussion of very slow interstellar colonization for making the trip to Alpha Centauri the slow way at less than 1% of light speed, by building outpost after outpost in deep space till there's an effective interstellar highway there. Even without something better than an Orion Drive for pushing your ship along, some of those improvements I mentioned earlier could allow that ship to be done far bigger and cheaper, relatively speaking. If you're sending a few hundred O'Neill-cylinder-sized ships out to Alpha Centauri, dispatching a new one every few months simply because your economy and industry is so impressive you can pull that off, then fast or slow, you are going to succeed at colonizing Alpha Centauri. The ability to produce a spaceship by asking some artificial intelligence to convert a big rock of an asteroid into a ship is also the ability to tell it to mass manufacture space habitats for people in space to live on, and that's going to rapidly improve your knowledge of life support and how to grow food and keep animals and people healthy in space. But it also means your civilization can churn out vast amounts of solar collectors in space, or that you can build so many space habitats that you can support trillions of humans in comfort. And those same trillions probably don't have to work as much, since that superior automation can produce all they need of most things far easier and cheaper and quicker than nowadays. In that sort of context, if a civilization of trillions with superior automation and interplanetary space travel can't find a way to get a colony ship out, either by having millions of geniuses researching new technologies, or by using the raw brute force of throwing resources at the problem, then it's probably impossible. I tend to assume we'll probably have licked the key problems before we even have a Mars colony worthy of the name, and that's the other aspect of this. Why are we going to Alpha Centauri? In the long run, as you get better and better at space travel and grow your knowledge and numbers, interstellar colonization seems an inevitability, if we don't kill ourselves off first. However, that first colony is not the same story. We're not talking about the conditions needed for us to do the trip in style and total safety, but rather the conditions that apply just enough to convince some powerful group, be it a specific nation, corporation, or unified humanity, that the effort is now viable and worth doing. And that's quite a limiter too, because again, we could have gone back to the moon any time in the last half century, as could really any of the major economic powers, if they felt it was worth the investment. There's not much to be said about being second. Most people don't know who the second person to climb Mount Everest was, either the Sherpa who went with Edmund Hillary, or the next expedition to succeed. The problem with Alpha Centauri, as things stand now, is that you're not likely to still be alive when that expedition arrives and reports back that it succeeded if you were the politician who risked your political capital to make it happen, or if you were the CEO who convinced their board or got the investors. Heck, you probably wouldn't even have your grandkids around by then. Missions to the moon or Mars you get to see happen, and people whose tax dollars made it happen get to experience it. Which inclines me to think that if there is a better option than the Orion Drive, we will be using it to get to Alpha Centauri, because we probably will discover it sooner than not. We've had some successes with fusion, including some recent ones producing more energy than put in for ignition, and I am optimistic we'll have working fusion this century, However, if practical fusion doesn't get invented 20 years from now, but instead 200, I would still expect the Orion interstellar vessel to be waiting on the drawing board or have only been deployed as an unmanned probe and prototype. I would bet if whenever it does get launched, it's either many centuries from now, when everyone feels better options can be ruled out, or because someone has managed to basically prove fusion, antimatter, black hole drives, and laser pushing systems are all eternally impractical pipe dreams, so it's shooting nukes out the back of a big spaceship or nothing. In the former case, you probably have had time for humanity to grow massive numbers in an emerging solar empire running on huge solar collectors too, in which case it is really hard to imagine how a power-rich system like a multi-AU long mass driver or laser pushing system for launch assist wouldn't be viable. Alternatively, if we have solar collectors and have refined beaming technology to the point we're comfortably able to keep a beam on a ship to the outer edge of the Kuiper Belt, either by very good lenses or by relays, then we can launch, and the same logic is true for fusion, but it really is possible we might have artificial black holes or straight matter-to-energy conversion by then too. I think almost anything that will turn out practical with enough science is going to get discovered in the next few centuries, and realistically we need that sort of timetable to build up around the solar system even if we have energy abundance and cheap spaceflight. It's just not the sort of process that feels like it's going to be rush. So by default we tend to assume a fusion-powered ship, drive, and life support, but I would argue it's just as likely we would have power or beaming, as the drive and power source for the trip would be fission or fusion. Beaming energy in during acceleration just circumvents the whole rocket equation issue, so it's hard for me to imagine anyone not using that. Breakthrough Starshot wants to do that with a tiny microchip sensor and thinks they can get to a third of light speed using only known science and tech and some reasonable near-horizon improvements. I was a big fan of that approach even before I got to meet and talk about it with Pete Worden, the former director of NASA Ames and now Starshot, and he made me an even bigger fan of the viability of that concept. It is not something happening next year, but it is definitely viable tech, and it can be scaled up. Everything can be. As we like to say on the show, if brute force isn't working, you're just not using enough of it. We've also detailed how to slow down with such systems if you have to, via a combination of Vanguard sacrifices to the sun and mag sails and other tricks. So that's my best guess for the future ship to Alpha Centauri, one running on either fission or fusion to keep the lights on, and something else for speed up and slow down, which would probably only take about 1% of the mission timeline, though it could be a longer portion of the trip. Mini drive systems work better when burning low and slow, like ion drives, as do free braking options like mag sails. Or maybe you have a higher top speed or need to go slow to avoid sloshing around the air and water in your habitation drums. Again, emphasis on plural, because while O'Neill cylinders are awesome, they are definitely overkill for a forced colony in terms of size, and you also want to have multiple drums or rings anyway, in case one is compromised. You can partition them into segments too, but it helps to have redundancy, and that's a good way to do it, especially since you might want very different conditions in some environments. Your optimized hydroponics hothouse conditions are unpleasant to live in for humans, and you also probably already know what the planet you're planning to settle on and what its day length and gravity are, so having a hab drum that replicates those conditions during the trip lets you start experimenting and adapting to those conditions, including having several generations of organism living in them to see what adapts best. As it is quite likely we will have ever bigger telescopes hunting exoplanets and small flyby probes arriving before the ships arrive or even depart, we may already have habitat cylinders devoted to mimicking conditions on some world around Alpha Centauri before we even begin constructing the colony ship. Indeed, it would seem logical to have purpose-built spin-gravity environments back here around our sun mimicking any planet we want to colonize long before sending missions to those distant planets. A cylinder habitat drum is likely to be far cheaper to build and operate than its spaceship version. Which raises two other points. First, is it actually a colony mission from the outset, or more of a classic exploration mission, or even something else? And second, are we actually going to Alpha Centauri or to Proxima? Proxima Centauri is closer than the Alpha Centauri binary, and not by a trivial amount. It's a fifth of a light year from the two big binary stars, hundreds of times further from them than Pluto is from our Sun, and we are not sure if it is actually part of the Alpha Centauri system, or is maybe a new addition or a passerby. They may not be gravitationally bound together as we initially assumed, but it's still a bit unclear. Whichever the case, Proxima Centauri is also known as Alpha Centauri C, with the bigger binary pair being called Alpha Centauri A and B, and they have actual names too, Rigel Kentaurus and Ptolemy. You can call them A, B, and C, but if you're calling the outer red dwarf Proxima, then A and B should be Rigel Kentaurus or Rigel Kent and Ptolemy. If you're curious, that roughly translates as Foot of the Centaur and two male ostriches, referencing their Arabic constellation names. They weren't known to European astronomers till recent centuries, and if you want to have a look at our possible new home system, you've got to be somewhere south of the equator since Alpha Centauri is not visible from the northern hemisphere. Incidentally, Beta Centauri is an entirely different star system in roughly the same direction, part of the Centaur constellation but nearly 400 light-years away, not 4. Alpha Centauri A and B are much closer to each other in position and size, being about as far apart as Pluto and the Sun are, and orbiting every 79 years. One is 91% of the Sun's mass and the other is 108%, though in terms of brightness that means the smaller is half as bright as our Sun, and the larger half again as bright. This does make for some interesting habitable zone scenarios, especially if we widen it outside the classic surface water case of being just a little warmer or colder than Earth so as not to be covered in ice or have its oceans boiling. Neither has any known planets, though we might have a mini Neptune or Hycean near Rigel Kent at potentially a habitable distance. It is even possible there'd be some viable colony options orbiting both stars. As we have noted before, the best colony options for interstellar civilizations are not necessarily classic habitable planets. Going back to the Alpha Centauri system, Proxima is a fifth of a light-year closer, which might shave years off a voyage, and the system does have multiple known planets, albeit we don't yet have great data to say too much about them with certainty. Proxima b is a planet 20 times closer to its dim red star than Earth is to our Sun, which is actually in the star's habitable zone because Proxima is so faint, and we think it's just a little more massive than Earth, somewhere between 10 to 25% more, making it one of the very few Earth-sized worlds rather than the giants we've found so far, as big planets are far easier to spot. We did select this planet for forced colonization in our Alpha Centauri episode some years back, and you can see that for more discussion of the topic. There's plenty of good reason to think there might be ice on its dark side. It is probably tidally locked, and if not, then it probably has water and air. We think those slow tidal locking down. But we are pessimistic about planets near red dwarfs, which tend to fluctuate in brightness a lot compared to our Sun, retaining their atmospheres. There also appears to be either a super-Earth or gas dwarf, Proxima c, about 7 times more massive than Earth, orbiting out as far as Mars would be in our system, though in this case that makes it less well lit than Pluto. It could be a Hycean planet, which can hypothetically support life even when quite cold, as we discussed a few weeks back. It is also a gold mine for anyone with fusion technology, and it probably has moons. Proxima d is a newer and softer discovery from about a year ago, and would be a sub-Earth probably bigger than Mars, but not by a lot, and it's even closer than B, getting nearly double the light that Earth gets, mostly in infrared, as that's virtually all the light Proxima gives off. That makes it a good candidate for terraforming using methods we contemplated in Winter on Venus for terraforming that hot planet. So all in all, as things currently stand, it would seem like Proxima would be the better candidate than the main pair, Rigel Kent and Ptolemy. It might be ironic then if it turned out Proxima wasn't even in the Alpha Centauri system, but just passing by. That would generally mean that we're not making the journey with any hope of making an Earth 2, and it is worth asking if we're even sending colonists on Mission 1. The usual notion is that since the trip takes lifetimes, there's no reason to even contemplate Apollo-style missions. Instead, you get to the other star system and stay, period, a permanent colony from the drawing board. I think that is true, but also feel obliged to point out that a civilization in the 22nd century is very likely to have radical life extension technology, as well as stasis options like freezing. They are fairly interconnected tech that are likely to be something where you have both, not either. So a mission there is viable, as you could be coming home to your actual family, and we might be talking a round trip of a couple decades, not centuries. Indeed, manned mission might actually be some uploaded human going out there with von Neumann probes to get some infrastructure in place for a future colony mission, and then it might just shut down and transmit a current copy of its mind back home at light speed to enjoy a parade in its honor when that person re-uploads into some android or clone or cyborg body. Indeed, that really does make a lot more sense than sending some AI out there as a vanguard, or some big colony ship full of thousands there as forced on the scene, with no existing supplies or infrastructure to rely on when they arrive. As for the journey itself, there is a lot to be said about freezing, but at the same time, the same technology that offers massively longer human lifespans, or restoration from decades of being a frozen corpse, also implies the ability of the ship to self-repair a lot, in which case the main advantage of staying frozen, less wear and tear from a warm ship and living crew, becomes less of an issue. And again, those automation and nanotech options that permit that are the same types of tech that let you start engaging in massive post-scarcity space civilization, able to churn out gigatons of spaceships and habitats. So I am guessing anyone making the trip frozen is doing so from a specific desire to help minimize their footprint on that ship, or that ship's footprint in their own life and experience, and I would be surprised if there wasn't an awake and active crew there for the entire journey, even if they're rotating who's not a popsicle at the moment. This does not necessarily mean we have a large awake community including children born on the voyage. Indeed, if the ship is a prototype, many might feel it reckless to have kids until they arrive and are settled in, especially if they have no shelf life on their fertile period from technological improvements to fertility methods and lifespan. As I've recently learned, little kids are very good at finding ways to poke at and break things, and not a good combination with a prototype vessel. You do need a lot of power to keep the lights on in a habitation drum, probably no less than 100 watts per square meter or 10 watts per square foot of cylinder living area or ring area. Some life forms are not going to do well getting frozen or being raised from embryos in some vat or bag without existing parents. They are generally going to be larger ones too, who would need more habitat space. This is a very tricky topic and one we explored more in our episode Exporting Earth, and we tend to hand-wave the assumption that our biology and genetics will just get way better before we launch colony ships, and that we will do it the big way, tons of giant space habitats flying entire ecosystems to their destination, though we explored alternatives including animal androids raising small critters, or even people. I tend to assume a bit of both, better biology and bigger habitats, not because you might not have the technology to stitch life together from scratch via nanotech when you arrive, but because again that same technology means you could stitch together continent-sized space habitats and massive engines with a little more patience and no more actual human effort. You just grow the ship from a template by supplying some asteroid to grow in along with a power supply, then load it and fire it off. As a journey on a tiny spaceship of half a megaton of mass, like the original Interstellar Orion design, is going to be way different than flying on some McKendree cylinder as large in living area as Eurasia, but the technology for sending them is the same. The only difference is one of scale, the difference between pouring a sidewalk from your house to your garage and pouring a multi-lane freeway to the other side of the continent. And the distance to Alpha Centauri is on such an immense scale too. The moon is 20 times further from Earth than any 2 points on Earth's surface are from each other, and Mars is vastly more than that, more like 10,000 times as far from us as we are from any distant corner of our own world. Alpha Centauri is more like a couple billion times as far away. That raises all sorts of other issues like what's keeping the crew from having a mutiny or going rogue when they are 100 billion times further from the nearest sheriff as any town in the Wild West was. That's a lot of time for folks to get weird or get crazy too. One reason why freezing the crew might be wiser, as you can probably make a more reliable AI that needn't have much more brains and free will than what is needed to thaw out a skeleton crew if various preset failures happen, or signals arrive, or you do, and so on. As to what might drive folks crazy on such a voyage, well, as we saw in our episode, Staying Sane in Space, the laundry list of psychological issues and agitators, even on the space station orbiting a couple hundred miles over Earth, is bad, much like submarines that prowl around the deep in our oceans for months. And this is like Submarine 1 or Spacewalk 1, so there's going to be a lot of tight budgets to make it happen and shave off any fat, and a lot of unknown unknowns to face with less resources than you wanted. So an interstellar mission can dial that up a lot, and this is Mission 1. So where you probably have decades of practice with space mission mental health issues, even deep space missions of a year or two to the Kuiper Belt, perhaps for comet mining, you haven't got tons of practice handling options related to interstellar travel. Like being a teenager born on a small ship and told you're stuck there your whole life. Like watching the clock mismatch a little more every day between your ship's clock and the news and entertainment feeds coming in from Earth. Like getting a message from your sister telling you your niece or nephew started college and knowing that by the time you got it, they either had already graduated or failed out. Like finding out the relative or pen pal you've been writing letters home to for decades and getting messages from died some years back and you just found out now. That even if you all have extended lifespans able to survive the voyage and early colonization and take the trip home one day, everybody you knew is so different that they may as well not be the same person. Like meeting a friend from elementary school decades later, there's just so much water under the bridge that you could run a hydroelectric dam off it, all of it spent apart from each other. For all the technical challenges getting to Alpha Centauri, I suspect the biology and medicine of surviving the trip and forging a new home at the other side will dwarf all the physics and engineering needed for that starship, and yet the difficulty of making that journey on the humans on board it may make both seem trivial. In the end though, I am convinced we will have the technology to do it one day, and no shortage of volunteers for that first mission to a new star, and that we will find people up to the challenge of journeying to Alpha Centauri, and that ship will unlock the gateway to a galaxy of billions and billions of new worlds. So if we make a spaceship that could travel to Alpha Centauri at around 10% of light speed, it would take 40 years to arrive. That's about how long someone's entire career lasts in modern times, and if this show ran for 40 years total, I'd have ended up producing about 3,000 episodes, and presumably spent about 80,000 hours, as that's about 40 hours a week for 50 weeks a year for 40 years. I love my job. I would be thrilled if I got to keep doing it for decades to come, and it really highlights what you can do with 80,000 hours, and I think most of us want to feel like our career really mattered and made a positive difference in the world, and would like to start or switch to one that did, but it's hard to pick one that our skills and interests align to, make a plan we feel confident in, and get ideas for high-impact careers. That's where 80,000 Hours comes in. They're a non-profit entity that spent a decade alongside Oxford University researching which careers have the most impact, and all the research is on their website for free. 80,000 Hours isn't the cookie-cutter advice we often see from schools or aptitude tests. No generalized platitudes and dull, repetitive advice about how you should become a doctor, teacher, or charity worker if you want to help the world. If your career is going to last 80,000 hours, it is worth spending many of those to find out what the real data and evidence suggests would be a good high-impact path for you, and spend some time with the curated resources you can find at 80,000 Hours, like their profile on space governance. Indeed, their podcast has covered some fascinating topics, like one of our favorite ones here, the Fermi Paradox, where they had on Anders Sandberg for a discussion of that topic. So yes, they are definitely including the kinds of topics that fascinate us when helping folks try to find a career they can love and feel good about doing. And again, everything is free forever, because they are a non-profit. Their only aim is to help solve global problems by helping people find the most impactful careers they can. If you join the newsletter now, you'll get a free copy of their in-depth career guide sent to your inbox. Just sign up at 80,000hours.org/Isaac Arthur. So February is drawing to a close, but there's still a live stream Q&A coming up this weekend, Sunday, February 26th at 4 p.m. Eastern Time, where we'll take live questions from the audience in the chat and answer them. After that, we'll start off March with one of my favorite topics, space habitats, on Thursday, March 2nd. Then on March 9th, we'll contemplate far longer voyages than the interstellar one of today to our nearest neighboring star, by instead contemplating voyages to other galaxies and even superclusters. Then we'll discuss how to survive various apocalyptic scenarios that weekend, March 12th, for our mid-month Sci-Fi Sunday episode here on SFIA. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon, and if you want to donate and help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service, Nebula, at go.nebula.tv/isaacarthur. As always, thanks for watching, and have a great week.